I called Steve on stage. He has come all the way from Delhi. He's a very active Delhi jug leader. In his own words, Paul is a patriot, a programmer, artist, philosopher, overthinker, and definitely a software development engineer at Finder. I will let him take us through his dummy startup that he has created, where he shows how data flows and how you can. Okay, I'll let him say what he wants to say with data.
So, hi everyone. I will just start presenting. I am actually surprised Jayashree remembered all of that. That is quite an amazing job that she did. Right. So, hi everyone. My name is Steve, and welcome to Navigating to the Data Landscape, from fundamentals to the future. I'll just quickly go through the contents that I will be going through. What is data? What is its importance? Data models, data storage. What is data replication? We'll go through data pipelines. What is data platform and its use cases? Data mesh and data as a product. So again, hi everyone, welcome to this session. I would also like to thank all of the organizers of Java Fest. They have done a commendable job for organizing this huge event. So a big round of applause for all of them. So yeah, about me, Jayashree quickly introduced me quite promptly. I am the JG leader at Delhi. I am the senior developer at Find. The project that I'm working for is called Boltic, which is a no-code, low-code data operations platform. So again, my name is Man, and I am not a data scientist. If you want to connect with me, these are the QR codes for my social. This will be at the end of the presentation as well. Just a quick reminder what this talk is. This talk is around building data applications. It is around data, forms of data, how data flows, how you handle data, and all of those things. This talk is not a course on big data. This talk is not an overview of data tools that you need to use. This is just an abstract talk about what you can do with your data. So what is data? This is the question. Can anyone answer? Yeah.
So information in bits and pieces.
It's information in bits and pieces. So what I did was I asked ChatGPT what data is, and I don't remember what ChatGPT said, because it said it is collection of information. It can be audio, video, visualization, these, that, and everything. And I was like, "Arey bhai, tum kehna kya chahte ho?" Like these things. So again, what data is? Data, rightly said, data is just information. Anything that you can measure is data. As simple as that. If you can measure the number of people in this room, that is a form of data. If you can measure the number of logs and errors that you're getting, that is data. What data is not is opinions, beliefs, and poems. Unicorns is not data. And why is data important? So data saves time. How many of you agree with me how data saves time? Okay, one agreement, two agreement again. So a lot of you are still doubtful that data can save time. Okay, imagine this. There is a restaurant and the waiter says basically, a person comes to order something. Based on the previous orders, the order book for the employee is pre-filled. You don't need to fill it manually all over again. It is auto-filled. You just change what you want to change. If a person offers cappuccino a lot in a cafe, let's say, then it will be pre-filled. It saves time. You don't have to go find that this is cappuccino. You don't want to do that. He orders 2 cappuccinos and all of that. He autofills. And this is basically how data can save time. This is a very mundane type of example. ITR filing. Data saves time. So income tax department has everything. So beware. Again, okay. So data is used to make informed decisions. So whatever decisions that you take, there needs to be a basis on what the decision is taken. What I mean by this is, let's say you want to open an ice cream parlor, and in that city you need to know what's the preference of users, what's the preference of people in this case. So somehow you do a survey, and in the survey people say that they love the butterscotch ice cream more than mango. I don't know what alien people are these, but still they say that butterscotch, they like it more. So you optimize all of your raw materials and everything, all of your processes for butterscotch. That is making informed decisions to optimize your costs. Again, personalization, customer understanding. This comes to how we save time. That same example, you understand the customer, you take their preferences, take their data, and give recommendations. This can be an example of this can be Netflix recommendations. Netflix basically says that you have watched this, you may want to try this. That is personalization and customer understanding. Risk management, again, since we have everything, we have logs, we have errors, and these sort of things, we know what the risk in our system is, and risk management, making informed decision, these sort of things overlap. Fosters innovation. Butterscotch ice cream, let's just imagine butterscotch ice cream didn't exist and they created the butterscotch ice cream. In that case, that would be an innovation, although I don't know how many of you would believe that is innovation. But yeah, transparency and accountability. ITR. ITR is a very good example of transparency and accountability. Data tells you exactly what the system does. It makes people accountable, it makes systems accountable, and it gives transparency to whole process that is happening. So what we are going to do is we will probably start our own company, and for this let's introduce FitSense, which is a fitness platform. The tagline being data, fitness and you. This is a data driven fitness platform which will work on making you more fit based on what you do and how we do it. So what we are going to do is build this whole application, build this whole company tech wise, focusing on data. So for this, initially what we do is we hire developers, and we hire not a lot of developers, we will come to that later, but initially we need to hire developers, we need to build data applications, and those data applications, we need to make sure that these three things are always there. Reliable, the application should always be reliable. If the application goes down, the customers are not happy. If the ice cream parlor goes down, even mango loving people don't like it. Scale. I think we have talked a lot about scale today. Almost every talk comes back to scale, so I won't be talking much about that. Maintainability. For this, there will be an example that a friend gave me. Once he switched a company, he wrote some sort of particular bad code, and some day later at night, a person came with a bat at his home, like, what the fuck did you do? Sorry for the language. So maintainability, that is what we need applications to be maintainable, to be sustainable, right? So coming to the data models that we have very basic data models. I'm sure most of you understand these. Relational model, we have the document model. Graph model has been picking up. There is time series data model as well. So I will just quickly go through these. In our case, what a relational data model will look like. Relational data model, in our case, let's say SQL. We are using MySQL. Our developers decide that MySQL is a good choice for this application. They create a workout table, they create a user table, they create fitness plan, they create exercise table. What relational model says is, along with storing data, you also maintain relations. So here you can see relations being depicted with arrows. Exercise ID, the ID goes there, fitness plans has multiple exercises and these sort of things. So relational model is basically data as well as relations. What the document model now does is, it saves everything as documents. So how many of you here code in Java primarily? Most of you. How many code in JavaScript primarily? You guys will love this document model. Right, so this is basically the same principle. You can do anything and everything with JavaScript, and you can do anything and everything with document model. That is a good thing as well as a bad thing. I don't want to start the war of relational versus document models, so I'll just go through the next one. Graph model. What graph does is it stores data in nodes and edges. It stores the graph of the complete flow. In our case, let's say we also create some sort of social media platform where people can post their workouts. User 1 creates a workout post, user 3 comments, user 4 comments on that particular post, user 1 follows, user 2. These sort of edges that we see, these sort of relations are better depicted in graph model rather than relational model. So there are use cases where graph model will be better. In our use case, for the social media part particularly, since it will be a very diverse network of users and posts and followers and creation of documents, creation of workout posts, so graph model in that case particularly would be better. Next comes time series models. Time series models just says that there will be tags and there will be fields. Tags is basically what you search on, fields is basically what you store, the measurable data. So in our case, let's say workout measurement, we have workout ID, user ID, exercise ID. These things are not measurements. This is not our data. These are just tags to identify the data. In a time series model, basically it will save fields like date, duration. Duration in our case, that this particular workout for this user, for this exercise ID, duration was this. So fields in time series model is what actually saves data. And like in document model there are collections, in relational model there are tables. Similarly here in time series model they call them as measurements. So again, exercise measurement, we have exercise ID that we need to filter through, and then the actual data that we have, the measurable data, we have name and difficulty level that can be used in other time series measurements as well. So time series model is basically more for graphing out based on time. So logging, for example, the Grafana dashboard that we saw, that is measurements based on time, the number of errors that came per hour, those sort of things. So Prometheus, you use Prometheus, right? Prometheus is a time series database. Now since we know how to model our data, how do we query our data? Again, querying is not particularly related to document models and these sort of things. Querying is completely a different topic, but generally what we see is SQL and relational have a particular query type, document models have a particular query format, and we'll be going to discuss all of that. We have 4 major query styles that we have. We have imperative style, we have declarative style, we have map reduce, and we have aggregation pipelines. So coming to the imperative style, I'll just, for simpler examples, I'll go to an example where we have a list of animals. Imperative style, which is also pronounced as YYDK, this is pronounced as yuck. YYDK means you do it yourself, so everything you do. Okay, in here what data means primarily, what people understand is data means databases. But in data structures and algorithms, data is stored in memory as well. So all of the lists, all of the graphs, everything that you store, stack, heap, that is also data, although we don't consider that as data. So before the Big Bang happened, before the universe was created, there were no databases. So developers that time used to do these sort of things. What they did was they told what they want to do and how they want to do it. All of the implementation, all of the nuances of getting the data, that is everything on developer. So this is the imperative style. Then came the declarative style. Like in Java, there was declarative style. What declarative style does is you just tell what you need to do, you don't tell how you want to do it. So in this case, let's say select star from animals where family is sharks. You are just telling it what to do. You don't care about how it is storing the data. If it is storing it in hash tables, if it is storing in lists, you don't care how it stores data, you don't care how it indexes data, you don't care how it is going to fetch the data. You just tell that I want all the animals where the family is shark, and you get it. That is the declarative style. Coming to MapReduce querying. MapReduce querying is a blend of imperative and declarative style. So MapReduce, how many people have used MapReduce in one form or another? Okay, nice. So what MapReduce does is, it gives you two functions basically, that you want to map and that you want to reduce. In this example, if we see, just for better understanding, we have a query at the bottom that filters out the data. All of the data that we get goes into the map function, where it emits it in a key value pair. So what is happening is, this particular key, year and month and that, year hyphen month, this will be the key, and the number of animals that we get is going to be the value. What reduce function will do is take all those key value pairs, and for each key value pair call the reduce function. In this case, what we are doing is we are just summing it. So in here we are telling it how to do it, but also not telling it how to do it. So this is a sort of complicated sort of thing that we did back then. This particularly was used a lot in Hadoop. This is also used in MongoDB, MapReduce. But what MongoDB did was, on top of MapReduce, it also created aggregation pipelines, where basically it made again everything declarative. So you just tell it what to do, and this will be the syntax. You first match it, then you group it, and then you just sum it. So these are the querying. These are the ways that we query our data. Does anyone have any questions till now? Just for a break. I need to breathe as well. No questions? Mm-hmm.
You said that there was a talk about three different sites, right? I mean, one is the not imperative. Yeah, can you just go back? I was this one. You see there also, yeah, here.
This.
Next slide.
Yeah.
Reliable, scalable, and maintainable. Why not secure?
Security will come. Initially, security may not be that big of an issue for a startup, if you understand this. Security comes when there is pressure from others. Does everyone agree with this? Security only comes when there is pressure from above.
No, but now the style is going leftwards, right?
Mm-hmm.
So to improve your security from the
Right.
start itself.
Right, that is actually a good point. For data intensive applications, we need to make everything secure. That is one point I agree I would miss. Again, thank you.
And yeah, moreover, the imperative style is now giving away to the functional style.
Right, again, for that declarative style. In SQL, this will be the declarative style. In programming, functional programming and everything that is coming up. So once we know how to query our data, sorry, question.
In the graph data model, are the nodes stored in any order, or do they follow like a topological sort of sorts?
In particular order should not matter. All that should matter is the connection between those nodes, which we call edges. It doesn't matter. It will matter once you go on the optimization layer. So all of the graph databases optimize themselves. In that particular case, it will be useful for storing it in a particular order. Otherwise, order in general for end user should not matter. Okay, let's come back to tags and fields. So what tags says is, tags is not a measurable component. Tag is just to filter out the data. Let's say in our example, workout measurement, workout ID, user ID and exercise ID, these are not measurable things. We just use this to filter our data, right? Measurable things is the duration, let's say. That is the field. Jo actual you plot it on graph, the data that you plotted on graph, that is fields. The things you need to filter out, get all the workouts for a particular user, get this particular workout ID, get this all the workouts for this particular exercise ID. All of that filtering out is on tags. Sorry?
In the graph database, where do you save all the fields
So basically, node is not a server in this case. Node is the representation. So like we have rows and columns. So node in this case is similar to rows and columns.
But there is a complexity that because storage cost and all, there is a lot of information in the node,
Mm-hmm.
and the graph performance will go down, right?
Again, that would depend on the internal implementation of how that graph database is implemented. For end user, it does not matter if it is performing well. If it is not performing well, then we'll have to go and debug how it is storing and how it is doing it. So for a, again, quick overview, we don't want to go deep into a particular graph database and how it works. Just for a quick overview, for the end user, what would matter is just knowing how it stores nodes and edges, right? Any other questions if we have? No. Let's store our data. So where do we store our data? In databases. In any of the companies where they don't store in databases. In memory. Does anyone store data in memory?
Yeah, we do.
Okay, how many people use Redis? Redis is in memory database. Again, there is a clash of things. It is also a database, but again, let's just say in memory is a separate thing. Yeah,
We store in Kafka also.
we store in Kafka also. That is okay. That is a completely different category. We will treat. So there are there is KSQL for treating Kafka as SQL and these sort of things. But yeah, in some cases, data is stored in Kafka as well. That is also true. So a quick overview on these databases. You all know MySQL, MongoDB, Oracle DB, everything. All of those databases. In memory, in this particular case, in memory was how the dinosaurs used to do it. That is what I meant by in memory in this particular case. Object storage is S3 and Google Cloud Storage. These will be the examples of object storage. People store data in files and directly upload them to object storage and for later retrieval. Logs in many cases are stored in files as well. We have data warehouses when it comes to large amounts of data. We have data warehouses. What data warehouse does is it is just a database with a lot of optimizations to handle a lot of data. So what database developers did was they wanted scale. Again, coming back to this particular word, they wanted scale. They wanted everything, every component of the database to be accessible while dealing with large amounts of data, and they created data warehouses. Data lakes is again something to store large amounts of data. The difference between data warehouse and data lakes will be that data lakes can store unstructured data like files, simple files. They have no structure. Logs from different systems, they can have different format. Data lake just stores raw data, and data warehouse stores all of the structured data that is ready for analytics. That is the difference between data warehouses and data lakes. You have a question?
AWS Glacier a data lake?
Sorry?
Is AWS Glacier an example of data lake?
AWS Glacier would be more of a data lake, but it has capabilities of data warehouse as well, I believe. I may be wrong, don't quote me on this, but I feel it is more of a data lake, right? So once our developers know, yeah, question. Okay. So once we know where to store our data, I'll just quickly go through the data encodings. How, in what format can we store data? People used to store data in XML. That was one funny time. And now a lot of people, again, JavaScript developers will like to save everything in JSON. Welcome MongoDB. Then there are people who save in CSV. So JSON, XML, CSV, all three of these I would say is human readable. And since they are human readable, they have some trade-offs. The major trade-off being size. When handling large amounts of data, size matters. And for this, Hadoop basically introduced Avro and Parquet. Avro and Parquet both are Apache standardizations. What Avro and Parquet are basically, if you people know protobuf, that is just protocol buffers. It stores data in binary encoding. Just the format of these two is different. Avro is a row-based data store, and Parquet format stores everything in columns. So that is the major difference. Otherwise, these will be a lot more compressed than JSON XML. I don't even want to talk about XML for data storage, because it is highly again, I'll skip that. CSV again, human readable and comma separated, that and that. Avro Parquet we have gone through. We have how to store our data. We have our data encoding. How do we pass data between services? Our developers already have created a lot of services in FitSense. At this point, you need to decide how different services communicate. For this, the first thing will be via databases. Again, this is a practice that not a lot of people follow, but this exists. So what they do is, a service saves data in the database, the other service reads the data from the same database. This can be considered as data flowing between two services. This is simple to implement. Problems are, this needs to be backward compatible, this needs to be forward compatible. For backward compatibility, what I mean is, if a new version of code changes the encoding of data being saved, then all of the system will blow up in this particular case. For forward compatibility, I will explain this in next slide. Data outlives the code. That is one principle that we have. So let's just say data written by new code has 4 fields. The old version of the code does not have a description field, and it goes on and saves the data as it is. The data will be overwritten and the description will be lost. This particular use case is very easy to solve. Instead of replacing the document or replacing, you can just update particular fields. It is very easy to solve, but these sort of problems exist. So communicating via databases is not recommended, and that's why most of you, I believe, don't follow this pattern. Next is via REST. How many of you build RESTful services? Okay, I expected to see more hands actually. So REST is basically the de facto standard right now. It is easier to develop. It is flexible. It introduces loose coupling. The front end and back end, they can be different components. REST, data can be transferred. Again, REST does not say that the data should be in JSON, although it says, but point is through network. If we consider this as data passing through network, there can be different models that the data can go through. It can go through in XML, it can go through in CSV as well, who knows. But again, REST is popular with community. There is a lot of community support. There are a lot of learning tools. There are a lot of people who will solve your doubts. So for these questions, just ask on the internet. And bringing the word microservices, that everyone seems to be fan of these days. REST introduces microservices, that's what I believe. Who needs an app when you have REST to keep you rested? So again, this basically shows the basic flow of what I want to tell. Data is being transferred over the network. That is the point here, that services communicate with data being passed over network. Next is async messaging. So this comes to the point that we store data in Kafka as well, but Kafka primarily is used to transfer data between two services. So that is event driven architecture. So what it does is it just sends events to a particular service. Instead of pulling the data from one service, the originator service is pushing the data to whatever client it needs. So huge shout out to the clients. It is fault tolerant. So if one of your client services goes down, data will be in the broker, in let's say in case of Kafka, it will remain in the messaging system until it is read. So this introduces fault tolerance. This allows us to scale our systems. This introduces loose coupling and again microservices. Right. So yes, we can handle data. Can we all agree? Up to this point, we have our applications, we have our encodings, we have our databases. The developers are happy. Everyone is working hard on making the sales work now, right? But as we scale, there are a lot of users that are coming. There are a lot of transactions that are happening. Not necessarily every database or every database configuration can handle that scale. So this introduces problems that queries being slow. Let's say the first challenge that a startup team will face, that the queries will be slow. So how do we go on and solve this problem? The first idea that comes is sharding. What sharding says is, instead of saving everything in one table, save everything in different shards. Let's call these shards as nodes. These shards are completely different servers, and data is split into these. So if a particular client wants to get the data with user ID, let's say 1, in the original case it will need to, in this example, in the original case it will need to query 4 rows. But if it is sharded, it will only need to query 2 rows. This can go up to scale. This is a pattern that a lot of people follow. All shards run on separate nodes. This is an example of horizontal scaling. You can add more shards, reduce a particular data set, and basically improve your queries. This also increases throughput since you are querying less number of rows. But the problem here is, let's say the second server goes down. We will not be able to query 3 and 4 at all. So sharding, although solves a few problems, it also introduces a few problems. In that case, what we need is data replication. Data replication is nothing but having a backup of our data. So in MySQL, a lot of companies follow the master-slave architecture, the leader-follower architecture. There are a lot of names for this. What this does is, there is one particular leader which handles all the writes. There are multiple followers which just replicate the data. This data replication allows us to segregate reads and write to improve performance. Second is, all of the heavy queries that we have can go into a particular follower. We can assign this follower goes just for the heavy processes. So with this, if a node goes down, let's say follower 2 here goes down, we still have one follower, we haven't lost our data. And let's say if leader goes down, there are cases in, let's say MongoDB handles primary and secondary. MongoDB says leaders and followers as primary and secondary. So if a primary node goes down, it assigns one of the secondaries as primaries. So that reallocation happens as well. So these systems are implementation of those databases itself. But the point here being, data being backed up somewhere is simply data replication. What this allowed FitSense to do is, we started to grow with the analytical team. We have built our applications, we have acquired a lot of users, we have sort of achieved scale. Now what we need to do is personalization. This is the main motive of the startup. So a lot of analytical queries are happening. Analytical queries are very, very heavy, and they have a lot of joins, they have a lot of this and that, this query, this data and everything. So what we do here is, we provide a particular follower to the analytical people, that this is your server, you just query from here, nothing else. Our main application will not be affected by your queries. This is the approach that somehow our developers went through. This also brings us to the point where we can differentiate between OLTP and OLAP. All of the transactional processing that is happening, OLTP stands for online transactional processing and OLAP is online analytical processing. So defining a line between analytical team and transactional team, that is what we majorly did with replication in our case. But engineers like to overcomplicate things. So what people said was, we need a completely different system for OLAP, which introduced data pipelines. So we had a quick overview of what data warehouse is. So analytical teams mostly work on data warehouses because of their big data handling capabilities. If you run a very big query, even with replication and sharding, a very big query can take down a particular database. So let's say, for an example, we have BigQuery as our data warehouse. The analytical team will work on that. We can use data replication to replicate our particular database to our analytical system, which in our case, for example, will be BigQuery. So this gives flexibility, this gives scalability, and this is separation of concerns. The analytical team will not fight with engineers, engineers will not fight with analytical team. So what data pipeline is, we'll start with the very basic example of ETL. ETL stands for extract, transform, load. This is a form of data replication that just replicates the data and adds another complex layer of transformations. What this does is, we have multiple DBs. These DBs can be anything. We extract our data from our DBs. We transform them. This transformation can include cleansing of data, formatting of data, and these sort of things, and then we load it into our data warehouses. This is quite similar to the leader and follower pattern that we saw. Just this is an overcomplicated version of this, and this was necessary. So ETL is simply data going from OLTP systems to OLAP systems for separation of concerns and these sort of things, and this in general is called a data pipeline. What people realized was, having transformations in the middle is quite a difficult task. That is hard to implement and these sort of things. So voila, extract, load, and transform. They just change the order. We have our multiple DBs and they dump directly into data warehouses or data lakes. One distinction that I would like to point out is, in the previous example it was just data warehouses. Since it is in structured data, any unstructured data warehouses cannot handle. In ETLs it will always deal with structured data. While loading, we can simply dump any form of data, any raw data directly into our data lake or data warehouses. So in ELT, data lakes are also supported, and after that we do transformation. So let's say if we are doing it with data lakes, we have tools like dbt and everything. We can make transformations after saving our data. So this, along with security and application layer, storage layer, ingestion layer, analytics layer, and data governance, this gives data platform. So again, what developers in our company did was, we have built almost everything. We have storage layer, we have ingestion layer, we have analytical layer, application layer, we have. Just add security and data governance. That makes it a complete data platform to be used by the company. Security layer, again, authentication, basic, whatever the application needs. What we did is built a whole application not for the FitSense, but just to handle the data of the FitSense. This is a complete different application, complete different suite of products that just handle data. So we have authentication layer, authorization layer, web applications, OLTP systems, databases, everything. Now here one thing is data governance. What data governance says is, data needs to be secure, data needs to be properly accessible, and only the authorized people should be able to access the data. It should be available. These are just principles that data governance says, and we need to implement these. Data quality needs to be ensured. We make sure that data is not missing in our pipelines and these sort of things, and all of the compliance related things that are happening. All of this comes under data governance, and data governance is a big part of data platform, right? Issues with distributed systems. Since we have built this complete distributed system, the issues can be system faults. What if our warehouse is down? What if the network is down? What if there's a nuclear holocaust? It can be anything. It can be complete failure, it can be partial failure, it can be unreliable networks. In case of unreliable networks, our data replication may not work, we may miss data. One With distributed systems, one of the concerns that happens is unreliable system clocks, since computers rely on system clocks to do everything, and if they are not in sync for whatever reason, it can severely damage our whole pipelines as well as the data. The next big problem is questionable reality. Let's say the amount of the order in our database is 750 and in the data warehouse it is 850. What will happen in that case? Which one is the truth? You will never know. These sort of things happen with distributed systems, since we treat databases as single source of truth in these cases, but again, we will never be sure in these cases what is the reality. So coming to the future trends, this is what the company has built till now. Coming to the future trends, what we can do. There are cases where we do reverse ETL. So everything, instead of going down, now goes up. Use cases for these, again, Netflix recommendation engine. Instead of, what the analytical team did was it found out the recommended movies for this particular user. Now the application to show it needs to have that data in the databases. It should not actually query data warehouses. So the flow going upward, that is reverse ETL. We have data mesh, which segregates data warehouses into different domains. So order team, sales team, everything, procurement team, they can have their own databases, they have their own ETL pipelines, ELT pipelines, whatever they have, and they share data among themselves as well. This introduces the concept of data as a product. So in here, domain 1, domain 2, domain 3, these are data warehouses, but these can be treated as different services which have data, and instead of giving APIs, that particular REST sort of thing, it gives data as a product. So if domain 3 wants data of domain 1, it queries that particular domain, and domain 1 basically gives it as a product, that this is my product, and it sells. Mesh, sorry? A data mesh is it's more about process than architecture. If you see point 1, this is just a process for decentralizing the analytical team now, right? Sales team will not be dependent on central warehouse, and they will not have the sales team want the data in different format. In ELT we can do that and transform basically in different sort of things, but in ETL we cannot do that. So reverse ETL and data mesh concept, these were introduced for these sort of things, that it is just for the sanity of the analytical team, right? And it is domain centric segregations. It gives federated governance. Each domain maintains and governs its own data and exposes its own data, and the data as a product, the concept that we talked about. DAP is just a mindset, it is not an implementation. It treats data as a valuable asset and exposes data as a product. The complete ownership of data is on that particular domain, and it introduces data interfaces in our applications so that other services can interact with this system to get data. So this is just a mindset. Yep, that's it from my side. Jayashree is very happy that I have completed finally, and I believe a lot of you as well. So feel free to reach out. That was all I had for data and data platform.